everybody. Craig will get the recording started here, and I apologize for any audio issues on my end.
The recording has started.
Excellent. So we're going to start off today's office hours with a presentation by the C3PO team, who
I love that name.
Yes, the Voltron team appreciates the C3PO team naming convention. And that'll be presented by Katie Wolf and Draguna Vrabi of PNNL. And so without any further ado, I'll turn it over to them. So you're sharing, you're seeing your, there we go. Draguna, if you're trying to talk, I think you might be muted.
Sorry for that.
No problem.
Stressful shuffling through my windows. All right. So thank you everyone for joining. I know you didn't join specifically for this project, but Katie and I asked Jeremy to have a few minutes in this meeting to introduce some work that we have been doing at PNNL over the past year, and to discuss some of the more practical aspects related to the implementation, and to get some feedback from all of you guys as practitioners in this area with respect to the usability and applicability and challenges that we might face when thinking about the tool that we're developing in the project. So the project is called Comprehensive Client Permissive Priority Optimization. And I am the PI of the project. My name is Draguna Vrabi. I am a senior scientist at Pacific Northwest National Lab. I have expertise in data analytics, optimization, and control. And I have 10 years of experience with applying my expertise in the areas of energy efficient buildings. And this particular project is going to be in that context. And let's see. Okay, so let me introduce you to the project. What we are trying to develop is a tool that can inform building owners and asset owners on their assets or building flexibility to provide particular grid services. So this is intended for users like you and me, right? Like homeowners or owners of real estate that is used as commercial buildings, basically. So we intended this tool to provide information to the owners of the assets regarding the flexibility of their assets to provide particular grid services, and to quantify the amount of value that can be extracted from the engagement in providing these grid services. One key aspect that we wanted to address was to account for information about the impact to the building occupants of using building assets to provide grid services. So at the end of the day, we wanted to enable building owners with information they need when they make decision regarding which programs they would want to enroll in and which assets they would want to enroll in those grid service programs. So this is a tool that would come in before they make that decision. It's a tool that uses data from your building, performs analytics on that data, quantifies the flexibility of your assets, quantifies the ability of your assets to provide particular types of grid services, and then informs you as an owner on what grid service you should be enrolling which asset in. So, as I said, this is an application, quote unquote tool. And as we think about an application, we have to think about how to install it, how it works, how to configure it, what information it will provide you, and how often. And at the end of the day, what is the value of this application to someone who is an owner or a real estate owner or a homeowner, right? So in the project, we're developing this application, and with this slide, I'm outlining what are the steps related to its installation and usage, right? So when first this application gets installed, it would be installed on some kind of platform that connects to data sources in the building, pretty similar to the Voltron platform or on the Voltron platform. It would, at installation time, it would be able to expose a list of assets and the data associated with each one of those assets, as well as the power consumption associated with each one of those assets, and the control inputs that are available for each one of those assets. And the user would be able to select particular assets that they would like to be considered for evaluation. Based on that selection from the user, the application would collect data from those selected assets, would create models that represent how those assets are being normally utilized in the day-to-day activity that takes place in the building, would analyze how those assets are utilized, and it would also analyze how those assets may or may not be flexible at different time of the day, the week, the month. And that flexibility would be evaluated, and then the assets that have been considered for evaluation would be ranked with respect of their flexibility to provide different grid services. So therefore, at the end of the day, as an asset owner, you would be presented with a list that ranks at the top, the highest flexible asset you have, and then at the bottom, the least flexible, to provide a particular grid service, right? So for different grid services, different assets may come at the top or at the middle or at the bottom. Each different type of asset or let's say appliance would change its flexibility and availability to provide its grid services over time. So on top of this ranking, we were also intending to provide real-time updates for how an asset may be ranked at a different time of the day, right? So this becomes a tool that will give you information in real time, okay? The goal of the project is to develop this tool, and we are demonstrating its capabilities on simulated models or emulators, high fidelity building emulators. We are not taking this tool to the field within the scope of this project, but we are interested in understanding what kind of field related demonstration issues we may find later on. beyond just quantifying flexibility for providing grid services, this kind of tool and the information that it collects and provides could also be used for better informing the building owner on space utilization, energy utilization, and occupant comfort. So this would be information that can help the building owner decide on other things, even if they may not want to participate or enroll any of their assets in any grid service. They will still get more information about how their building space is being used, how comfort is being provided in the building space, and how much energy is being utilized for which energy consuming asset or device. So I want to dive in to outlining the interface that we developed so far for installing the tool. And I'm not going to go into any details about the analytics and how it works, because my intention was to get feedback from all of you on how we develop this interface, what it can do, what it cannot do, what it should be doing, what would be nice to have, and kind of get your feedback so that we can have a better understanding of what would be acceptable, what would be nice to have from a user perspective. And I feel that all of your experience with Voltron and deploying applications on Voltron would have a strong voice here in our project. So going back to the interface, at the beginning, this is an application that requires access to data. So it would be deployed on some platform like Voltron. In terms of configuration, the first window here shows that a user would be able to select what type of building they are installing the tool in. So you can pick small size office, medium size office, large size office, but also any other kind of commercial building also can be selected. Then you open a configuration panel where you just select the number of floors and zones that are present in the building. So you can select a particular number of floors, then this interface would change. You would get this, the number of floors you selected, and then you can select how many zones you have in each on each floor. There is a nuance here. Zones and rooms could overlap. So because we want to look beyond the building level assets, which are typically like HVAC systems, I would encourage everyone to think about zones more in terms of rooms. Okay, and then based on this configuration selection, you will get a summary panel that kind of indicates the structure of the building without zone-wise, without any specific indication of architecture. Okay, once this is configured, and this should be very simple, 3 easy steps, this information gets saved in a JSON file, and for each particular zone, you can select what building loads you have present in those particular zones. So, for example, you can select at the first floor, zone 2, you can select that you have an HVAC system and you have a lighting system. And for both of these, you have a meter available, right? So you would be able to select what you have in those particular zones. Other things are also available in a drop-down list. And you can also add appliances or assets that are not present in these lists if you want to configure further for your particular building. After the configuration has been done, you can also take a look at the data that is being acquired from those assets. And that is a state at which the tool has been informed about what assets are present, what assets are to be evaluated for their flexibility and availability to participate in grid services. And then the tool would start collecting data from those assets and start the analytics portion of its capability to learn how energy is being utilized in the building and how different assets are being used by users. At that point, there is not much to display. It's a stage in which the tool is learning, pretty much like your Nest thermostat, which is learning your typical behavior. And you can just simply take a look at the data that is being collected and that is informing the tool's learning methods. Once the learning has completed, you can select different types of grid services that you would want to evaluate your assets for. And based on your selection, what will happen is that for a particular grid service, the assets that have been selected will be ranked based on their ability and flexibility to participate in those types of grid services. And this is dynamic ranking, so it will change over time as you continue to collect data and use the building. You will see how this ranking will evolve over time. So I'm not doing a demonstration here. I'm just giving you a flavor of the types of things that we can compute today. Now, at this point, I want to pause and I want to open it up for discussion. I would be very happy to hear all sorts of comments, suggestions, questions, ideas on how we can think about this tool better.
So Dagruna, in a Voltron building, those devices would already be defined. So there might be a way to leverage the Voltron driver definitions to populate some of this.
Okay.
So that could be interesting to explore. And then another comment. So you're defining, or you're finding which devices are most flexible to use. I'm wondering if that might feed into things like intelligent load control.
Yes, that is a very good point. With this tool, we are not deciding on any type of control that would be used. We are simply just analyzing data and quantifying flexibility of assets in absence of any kind of control method to be later on implemented.
Right, but you could inform things like that.
Exactly. So this is intended to inform control methods like intelligent load control about the flexibility of these different devices that they may want to consider for control.
Okay. So yeah, so it seems like it could, for people who are developing applications in Voltron or buildings in general, they could use this to identify where they might play or where they might have the most impact with those algorithms.
Exactly.
So there's a question from Dan B. What do you envision as the data collection suite?
I don't know, like, what are the specifics of that question. I would imagine that we can leverage all the capabilities that are provided by Voltron and the ability to collect and store data in the historian, and then read from the historian and analyze and basically operate on the historian collected data and perform the analytics. Is that what the question was geared at?
I believe so. And so you're going to reiterate, for the duration of this current project, you're working in simulation, right?
Yes, we
So
are working in simulation. We're developing the analytics. We want to make sure that the methodology is working and that we have some validation proof, mostly using high fidelity emulated environments.
So since you have such high fidelity environments, how do you suppose the transition to real building where you may not have as many sensoring capabilities, how do you see that trade-off?
Yeah, that is a good question. When we proposed this project, we were envisioning a situation when the building appliances or systems would have sufficient metering and controls and data collection, I mean sensors, to support grid response type behavior. So we are assuming that power meters, sensors, and controller inputs are available for each device. And most importantly, power meter is very important in this context, because it's unlikely that one can provide any kind of grid service and unlikely that that provision can be quantified if you don't have power measurement capability. So I think the short answer to this question is that we are assuming buildings that have more extensive metering than just traditional existing buildings.
So would like 3820, would that have sufficient metering?
I think so, yes. 3820 is very well instrumented, and there is metering even at zone level, even on the HVAC system.
So you could take a look at some of the Voltron campus data then and see, as kind of a first cut of, would this work in a, how would this work with real data sort of thing?
Yeah, and that would be even before you actually hooked it up to the building, because
Right.
we've got years of data.
Exactly.
For that.
Exactly.
Yeah.
So yes, before this can before the operation is as an online tool, we can actually apply the analytics methods on offline collected data from the past. Yes. So that would be nice to have in the project.
Okay, yeah, we should talk after this. That can be arranged.
So question.
Yes.
This is Dave Raker at the University of Toledo. So we are building out a transactive energy network on our campus. And the way that kind of works is that you have a set of forward intervals in the future where in order to schedule and participate in markets, you have to be able to estimate the flexibility of devices in those future intervals. And of course, that's not static. You're going to have ambient conditions, outside temperature, radiance, things like that are going to affect the flexibility of stuff in the building. You made mention of providing real-time estimates of flexibility. Do you envision any sort of functionality for estimating future flexibility under some given set of ambient conditions from a forecast?
Yes, that is a great question. So we started with just static estimates on like current state estimates of flexibility. In a control context, forecasts are very important. So we realized that early on. And we selected a methodology that uses probabilistic models. So we can forecast, we can give you a probability that a particular asset would be available or basically in the correct state at a future time interval. And that is because we accounted for the impact of occupants in a stochastic framework, right? So occupants are utilizing devices or making use of any kind of asset you have in the building. The behavior of the occupants and the way they interact with those devices has a stochastic nature. So it's not entirely 100% predictable. So our analytics framework is accounting for that, and the kind of information that we can provide is how much flexibility a particular device is likely to have in the future based on forecasts of outdoor air temperatures and things like that. And what is the probability that that device would be in the right state at any time interval in the future. So we can pick a particular prediction horizon and we can define what the time interval is. It could be 5 minutes, 15 minutes, half an hour, and so on. And then we can use the model, the data analytics and modeling framework to find these probabilistic models, and then we can use those models for forecasting. As long as your algorithms for transactive energy can make use of stochastic inputs, as long as we all agree that these are not deterministic predictions, I think this the data that comes from this tool can be used for forecasts and for integration in transactive energy concepts.
Yeah, I mean, we can certainly deal with issues of certainty in terms of forecasts, but I mean, what we would need to see would be say not just whether device is in a state where it can offer service, but kind of how much it can change its power in either direction with what sort of certainty in future intervals, right?
Yes, and in addition to that, we can quantify what will be the impact on the ability of that asset to provide comfort.
That's good.
Right. So not only we can tell you how flexible an asset is, but we can tell you that if you want to take advantage of this particular amount of flexibility, you have, a 10 or 20% probability to impact the comfort that typically that asset is providing. And that notion of comfort is different for different types of systems. So it could impact the comfort with a certain, by a certain amount. So this way, it offers the ability to understand the trade-off between comfort impacts and the likelihood that you can deliver a particular service that you committed to.
Good, both of those are important. What kind of time frame? I get the impression you're fairly early in this still. What sort of time frame are you looking at for developing this?
We are very we're not that early in the project. We actually have already published or we have an accepted paper that will be published at the conference in September. And that paper captures all the details about the analytics and the type of data that we're using, and the impacts of selection of different types of systems, and the way to compare different priorities, because certain users may care more about comfort than others. So we already have developed the framework, the analytics framework, and we also have developed a, let's say, a prototype, very early stage prototype for this tool. And we are currently integrating everything with some of these more higher fidelity simulation models.
Okay. What conference is that going to be at, or?
It's a mechanical engineering conference. I forget the name right now.
So I'd be interested in seeing your paper.
Yes, and probably now that it's accepted, we might be able to share a preprint on archive.
That would be good. Yeah. Should I contact you then to?
Yes, I'll be happy to share all of that, and to even have further discussions if you're interested in the analytics portion of this project.
Sure. What's your email?
Can you paste it into the chat, and anybody else who has the same thing can grab that as well?
Okay, so chat. Oh, yes. I'm sorry, I should have put that on the slides.
Well, and I can email it out too.
There.
So I have a little bit more, I guess, philosophical question. You're asking about the interface for the user, and I guess my question is, what do you think either the owner of the building, or I think it's a pretty far stretch to think of residential owners caring about this enough to go through this process, but like, is that really the right user for this, or is this more of a like, I've got customers who are utilities who I think would be really interested in this, where they're more hands-on, beyond a normal utility model where they might have ownership in some of the assets and the buildings and that sort of thing. I would see them finding this really valuable, but they would have maybe different expectations of the interface than looking at it from the perspective of of a building owner or a homeowner.
That is a great point. So actually, we were wondering about that as well. So this tool, at the end of the day, is doing data analytics on building data, but the results, the information that gets extracted, could be very useful to different other types of entities, including utility companies. So that is a great point. And that's why we are presenting this project to you, because this kind of feedback is important to us to figure out whether this user interface would be generic enough or useful enough for a utility company. Personally, I don't know. I do not have experience with programs that maybe utilities are considering. So
yeah, and I think like the residential thing is just kind of scary, because it takes, there's so little gain to be had there in a net, like looking at it on a per house. So the only way this would be really interesting, even if not for the homeowner, for the utility, is if you're thinking about it in terms of cohorts of hundreds or thousands of homes, which is probably a very different kind of approach than on a one-off per site basis. but it's super. And the thing I'm thinking about is like, how does that affect fund? Like, what kind of funding opportunities you pursue to continue building it out? Because I'm very excited about what I see here. I think it has a lot of potential, and so I'm hoping that you're able to continue working on it.
So one of the things that we would like to do, this is Katie, one of the things we would like to do if people are interested is set up some one-on-one conversations to kind of walk people through a very informal series of questions. And we really want to kind of identify those use cases that are of most interest to a possible user community. And if you would be interested in participating in that, or if you know others who you think would value from learning more about this and exploring it with us, we would love to either have you guys drop Pravina an email or email Jeremy and he can forward it to us. And we would then be very happy to set up some one-on-one phone calls.
Yeah, I'm nervous. Like, I'm happy to talk more. I'm nervous about, I would love to have you talk to the utility that I'm talking about, because I think they would be very excited about it and it would help them continue to see more value in Voltron. The challenge is, as soon as they see what you're doing, they're going to want it to have been done yesterday, and want a commercially ready version of it. So that's that's what I'll have to balance. But I'll see if there might be some interest as kind of a future looking perspective. But yeah, it's very exciting.
Yeah, having also talked to some of the utilities in this area, which this is a deregulated market, so they're often distribution transmission companies without generation. I get the impression that some of them are looking towards energy services offerings to their customers beyond what a utility traditionally does. That this sort of thing might be of interest for, even at the residential level.
I mean, the entity I'm thinking of is specifically entering a I think recently deregulated market as a retailer only, and their whole idea, concept is to take over operations of existing assets in commercial customers and add ancillary grid services assets across their network on the sites who are their customers, like grid storage and that sort of thing, that allows them to operate their entire customer base in a much more agile way on the spot market. So exactly those kinds of models. I think they would find this really help them evaluate deal flow and all kinds of value streams off this.
Yeah, so as Katie mentioned, we would love to have those kind of conversations, because we do see that there are different ways in which this information can be used, and we would like to better understand what are the approaches they're taking today, if there are any. What do they find challenging in general? How would they like this information to be presented? The neat thing about what we're doing is that this is an analysis that is being done with your data on site, and the results of the analysis can be the results, namely the ranks, the information about flexibility. That kind of information can be provided to the utility company, so that if this would be deployed or installed in an easy way to many different buildings, then the utility would have better visibility into how its customers are using the energy and how much flexibility actually exists in the system. And then that would inform their decision on what programs, what demand response programs they may want to instantiate. And all throughout, the actual data of the customer never really crosses hands. It never really goes to the utility. It's just this high-level information of flexibility and assets. So the actual data of the homeowner or building owner goes anywhere.
I mean, I think that might be important when you start talking about homeowners, but then you also are talking about deploying infrastructure in people's homes to run this, which is a management and budget challenge, honestly. I don't think the kinds of utilities who would be interested in gaining value out of this are going to have those kinds of struggles with their customers, because their customers are already bought into a partnership with their utility in order to reduce operating costs. It's an interesting, like, philosophical position. I just doubt that it has a lot of value in the market.
Okay.
My opinion. I mean, we may be doing this one-on-one right now in front of everybody. I'm sorry, but I did have one more question, which is just, I understand you've been focused on getting the analysis right, getting the results of that published, and using simulations to do so. Do you have a concept of any sort of, like, what the trade-off is going to be when you go to real data? Like, is there, if you can get 100% of the information you had in the simulation, you have 100% of the value. If you get 90% of the information, do you have 90% of the value or 80% of the value? Do you have kind of an idea of what those trade-offs might be when you go into a real-world scenario?
I think it will depend on the types of assets that you want to analyze, right? So we kind of know what are the big power consumers, and we kind of know what flexibility percent-wise those big energy consumer systems have. So if one would focus on deploying this tool on those big assets and not worry too much about these many miscellaneous electric loads that could also be considered upfront, I think that would bite into the biggest amount of flexibility first. And if when that becomes successful and the owner actually sees that this is valuable for them, then they could consider instrumenting other things.
Awesome. Thank you. Thanks for presenting.
Thank you.
Yeah, that's great. Great feedback and conversation. Any other questions? All right. Well, I sent out an email with Draguna and Katie's contact information if you want to follow up with them directly. I think we look forward to another presentation by them in the future when they've got some new progress to report, or maybe presentation of the paper or something like that might be interesting.
Yeah, thank you very much, Jeremy. So we'll be happy to. I think we can put together a presentation about the actual technical details, maybe in a couple of months or so, just so that we don't take every single meeting you have.
Yeah, no, that sounds good. All right,
thank you for having us.
Yeah, thanks a lot for presenting. And just as a reminder, if anybody else on the call has research that they'd like to present at a future office hours, just let us know. We're more than happy to see that kind of research presented to the community. We've got about 10 minutes left, so I'll just open the floor for any other, any questions or comments just in general before we wrap up here.
I'd be interested if anybody has attempted to use the Docker recipes that we showed a couple weeks ago.
Ansible, not Docker.
Yeah, sorry. Excuse me, Ansible. Yes. Sorry, Ben. That's what I meant.
Dave, you seem most interested in it after that presentation. Have you had a chance to try it out yourself, or still?
Not yet, but will be very soon.
Okay. Yeah.
So there's some new things going in probably next week that that will make it even better. So
Great.
So in what context are you using Ansible versus using Docker?
So
go ahead, Ben.
so the recipe system is built on Ansible for deploying and configuring Voltron on remote systems. And there have been various kind of pieces for using Docker. We've got some unit testing and integration testing stuff, I guess mostly integration tests that we're trying to run using Docker. Craig, I don't know if anyone has used Docker deployments externally or in kind of any actual production system.
I am.
Oh, you?
Excellent.
Just now, and only because ORNL is.
Is that based on the Docker repo that we have, or have you rolled your own?
This is I'm pretty sure, I'll have to check with the guy who did it. I'm pretty sure this is a own rolled Docker Compose project. I haven't looked at the official Docker stuff in like probably since when Craig first worked on it. So that's been a year and a half ago or something, or longer.
Yeah, it's been a while since I've looked at it too. So
Yeah. But if y'all have added to it or improved it, it would be nice to know, and maybe we could integrate it into some of the stuff we're doing.
um,
And especially if you have Ansible playbooks for building the Docker containers, that would be interesting.
Now that we don't have, but
Okay.
Ben did some stuff that allowed the Docker containers to be multi-specific. So ARM versus 64.
Oh, yeah, we could definitely use that.
So that's one thing that we have done. I actually did some research and found a little bit better way of doing it, but because the Docker daemon itself has upgraded since when Ben did the stuff. So it'd be interesting to relook at that.
Well, and I guess I was asking, like, you all were playing with Docker deployments. Now you're building out Ansible tooling. Like, is it because you're using Ansible instead of Docker, or are you using them for two different things? That's what I was trying to get to with what's the context.
I think that we are going to be pushing for Ansible on our main campus, just because then we don't have to install this other thing. But yeah, so that's all the history is. I like running the stuff in Docker for our tests, because we can spin up a crate DB and talk to the others just by spinning up a new container. So that's where our testing is going, is to have these other assets that can be spun up and connected to, and then we can run individual tests in a contained environment and not worry about them colliding, and hopefully make the testing experience more robust.
I have a hand grenade question, but I want to make sure with 8 minutes left, and if nobody else has anything else, because I've been talking a lot, but I also haven't been here in 6 months. So.
All right, go for it.
Should we turn the recording off?
No. No. DB, I don't think I was around for the original reasoning for DB funcs being in the platform instead of in the various historian agents. What's the reasoning there? And yeah.
So the reason that was written that way was the base historian allowed us to just to allow the DB funcs to dynamically load up whatever we needed in order to do the connections. and that was a central place for them to be there. Rather than have them in the individual classes, we could test them independently of the agent, and be still referenced by the agent using a standard API.
But the problem is if I want to update the definition of my database or just the historian itself, I have to update the entire platform and make changes to the entire platform. So from like a long-term management, it sucked for me. So I was just curious if there was like, I get it from testing, and maybe we just need to figure out a way to like, I don't know how you would do that and still test it if the agent, like you could say like if an agent is in core, well, you can import from the services, part of the, but if you have a historian that's outside of that, then I guess you just wouldn't be testing it anyway.
Well, the other way you could do it potentially is you could probably put a symlink in the base to extend something different, right?
Yeah, but that's still,
something like that.
You're breaking all, like your interfaces are supposed to be, you have a platform that provides messaging and you have agents that do things.
Mhm.
And that's broken here because there's dependencies that are not agent interface and agent platform interface dependencies.
Certainly something we can look into.
Yeah, I mean, if it's causing issues for someone who's trying to use the platform in a deployment, then that's something that we need to take a look at.
I'm happy to help or think about it more.
Yeah.
But like every time, like there's been a few times when I've like, oh, I could throw together a quick historian that would connect to this other system and like that would handle things for me. And it's like, oh, but then like I have to break the historian. Like I can't use the base historian quite the way it should be used because it's going to try to look for stuff in the platform that isn't there. It's nothing that can't be worked around. It's just it's like a weird,
Yeah.
a lack of separation.
Something, I mean, certainly talk to me about it. We can definitely, we want it to be useful. It would be even great if it was, if there was extensions that you could add, like that would build out your topics table, right? Because your topics table has like 40 more columns than ours does, right? Ours has 2 or 3, maybe, right? Or something like that, and have that happen automatically or whatever. Yeah, certainly.
Okay. Sorry.
Well, it has not caused me problems. I've noticed that and wondered about it too.
It has not, or it has?
It has not, because I haven't tried to do what Andrew's doing, but
yeah,
I've noticed that and wondered about that.
Yeah.
I mean, yeah, it's been there a long time. I noticed it a long time ago.
Since 4, so I mean,
yeah, it hasn't caused me a problem. It did until recently. It caused me a little bit of problem on like some real like production stuff, and I just worked around it. And like basically, I think at this point I may have I'm deploying from a branch that has a modified DB funcs because that's what I had to do to get it to work.
Yeah, well, let's follow up after this then and see.
And then, but I, like a few weeks ago, I was like, I'm just going to build a MQTT historian, and
rather than use the one that's there, which may or may not work. I don't know.
But maybe it wasn't that. Maybe, but there's something where I started to just like rip something out over a weekend. I was like, oh, wait a second. If I deploy this, it means I have to like add a bunch of stuff to the platform, shut down that device, and change.
Yeah.
Nope,
no, I get
fair.
it. Yeah, totally fair. We'll follow up. We'll follow up with you after this, and yeah, we can certainly talk about re-architecting some stuff for sure. That's part of. Well, I don't know if I don't know if I can say that or not. So potential next year plans, I guess.
Well, let's scope it out and see what it
Yeah.
would take, and then we can figure out where we need to do it.
Yep.
Okay. Well, thanks, Andrew. That kind of feedback is what we're looking for here. So
Most definitely.
good to hear.
And then, of course, I don't know that there's a whole lot of folks that don't already follow the GitHub, but I would love feedback and comments and more engagement on the Modbus TK stuff, because I'd really like to get that to a feature level where, you know, it's doing everything. And I've been working on it a good bit lately on some other stuff, so it's a good time for me.
I will get you some feedback. I haven't had a chance to play with it right now.
Andrew, do you want to maybe talk about it at the next office hours?
Potentially. I guess I don't have a lot of I don't really know.
Well, even if it's just to highlight it and maybe.
Yeah, try to have a conversation.
Yeah, I mean, that's a great idea.
I kind of spent some time, I'm sure y'all saw me commenting on issues from 4 years ago and all that. I spent
Keep
a night
doing that. That was great. We enjoyed that.
Diving in and just thinking about potential issues for newcomers to the platform. And I think it's actually good news from the perspective of things are happening that I think are driving people towards platforms like Voltron. So I think there'll be some, renewed interest in this. And it would be nice to make sure that it seems, that there's maybe a little more of a clear path to do things than maybe is available now. Sometimes it's a little overwhelming. There's so many options.
Yeah,
so.
Exactly.
Yeah, flexibility is a double-edged sword, right?
Yeah. So I think that's kind of the broader context of that. It seems like there was pretty good consensus that the Modbus TK works better in most applications. There seems to be a special scenario, which I think I understand the limitation that's causing that, because there doesn't really share a driver between device classes, or it doesn't share a Modbus TK client between devices, which is a pretty big shortcoming, actually. I mean, I'm surprised it's only bitten this now, but it might be worth digging into that a little bit more.
So we got you on the hook for 2 weeks from now.
Fine.
All right. And it's recorded, so we can point to it.
That's true.
All right, guys, I'm turning the recording off.
All right, thanks.